Hi, stat students. Today we're going to learn about a one sample t interval for mu. So that's going to be the focus on this week. Then next week will be about the one sample t-test for mu. And then the last week of school, we'll review them both and test. I hope everyone had a great weekend. Let's begin. So the goal of today is we're not going to do a full one sample t interval for mu. We're just going to learn about something called t star, okay? And then we're also going to learn the state and the plan of a t interval. So without any further hesitation, let's get going. For a one sample t interval for mu, you need to make sure that you know how to find something called the t star. So I have three different examples here showing you what you're going to have to do to find a t star. And the t star is not going to come until tomorrow, but we want to just practice today how we find it. It's pretty easy once you get the hang of it. So hopefully by the third example, you'll be okay. If you have any questions, feel free to reach out to myself or Mr. Jans, whoever your teacher is. So the first thing we're going to look at when we find t star is what is our n, and n is how many people were being sampled, okay? So if I'm sampling 10 people, n is equal to 10. The next thing we want to look at when we're finding t star is the confidence level. So I just made this confidence level up. That's the 95% confidence level. Okay, here's the work that you have to do. So the n will be given and the confidence level will be given. What you need to do is you need to find something called the degrees of freedom, okay? And the degrees of freedom, we usually write as df, okay? And df is equal to n minus 1. So for this example, our degrees of freedom would be n minus 1. So that's 10 minus 1, which is equal to 9. Okay, so that's the first thing that you have to do. You're given your sample size, your n. You're given your confidence level, this 95%. And now you have to find the degrees of freedom. And we call that df, n minus 1. So our degrees of freedom is 9. The next thing that we have to do is we have to go to our table. And this will be on Schoology. It's also in your notes here. And we see this table. And you saw this table before in our last unit. And all you used in the last unit was this infinity row. That's your Z stars, okay? We're still going to be using these confidence levels, but now what we're going to be using is this DF. We're going to ignore this top row for now. That's not until next week, okay? So what we have is we had our degrees of freedom. Let's just double check so we know. I think it was 9. Yeah, we had our degrees of freedom of 9. So I'm going to find that df of 9. So that df of 9 is right there. And I'm going to highlight it real quick just to make it easier for us. So there's our degrees of freedom. My mouse is not very good right there. Sorry. I have my mouse on my son's book and it's just a little bevel in there. So, okay, now we go to the confidence level. And we said it was a 95%. So I go to 95%. And I'm going to scroll up. I'm going to keep scrolling and I'm going to see where they intersect right there. So degrees of freedom of 9 with a 95% confidence level, our T star is at 2.26. So let's write that down. I think I screwed that up. Did I say 2.26? 2.262. Forgive me. Okay, so let's practice it again. We have another one. N is equal to 25. Now, if you think, oh, I got this, I want to just fast forward to the next thing. There is a little bit of a plot twist, okay? So you want to hang in there with me. Let's practice N is equal to 25 first. Okay, so we have N is equal to 25. We have our 90% level this time. We need to find our DF. We just said our DF is N minus 1. So that's going to be 25 minus 1. That's 24. We're going to go to our chart. We see 24. Let's go to the highlighter. I'm going to highlight across. Oh, I don't like that. Control Z. Let's do it a little better here. It's hard with a mouse. Okay. And this time, right? This time I don't have 95%, I have 90. So I go to the 90, I scroll up, I see where it intersects. Oh, it intersects right there where it's all dark and we can't see it. So I'm going to undo it. And you can see right here, it is at 1.711. Let me undo that again, forgive me. 1.711. Okay, so that is our 90%. Intersects at 1.711 for degrees of freedom of 24. Okay, so let's write that down. Okay, and now we have the last one. N is equal to 50, and this is where our plot twist comes. Okay, so we know that we have degrees of freedom. Forgive me, give me a second. My cursor is so slow, okay? We know our degrees of freedom are equal to 49. Let's go, and we know it's a 99% level. So let's go to the chart, and we look down for 49, and we don't see it, okay? So when it's not on the chart, what you have to do is you have to round down to the next degrees of freedom that you see. You would never round up, you round down. So my degrees of freedom are 49. Well, I don't see 49 on there. Now, I know 49 is closer to 50, but if I round down, that's going to get me to the 40 degrees of freedom. So for example, let's say our degrees of freedom were 950. 950 is so much closer to 1,000 than it is 100, but you have to round now because it's not on the chart. I am not going to round to 1,000 because that would be rounding up. I need to round down. So 950 rounding down, the closest one on the chart then when we round down is 100. So we would use degrees of freedom with 100 there. We're not doing that one right now. Our degrees of freedom are 49, so we have to round down to 40. Let me get my highlighter. Here's 40. Let's see if I can get it straight. And I'm going to stop there because I see I have 99%. I'm not going to highlight it. I'm just going to say, hey, here's my 99% level. I know it's a degrees of freedom of 40. I scroll up. That gives me a T-star of 2.704. So I'm just going to make a note that I had to round degrees of freedom to 40. And I think we said T-star was equal to 2.704. Okay, so that's the first thing that we need to learn for this lesson. The next thing we need to learn is how to do the state and the plan for finding a one sample t interval for mean. Let me just remind you, what is an interval? An interval is giving us a lower bound and an upper bound to tell us, hey, we have very plausible values for the truth about a population. Before we were doing it about a proportion, and that was dealing with categorical variables, like what proportion of people are going to go to the U of M. But now we are dealing with quantitative variables, and that's where we deal with the means. Okay, so let's go and do that now. So I have this problem here. So we're going to do the state and the plan today, okay? And then tomorrow we'll finish up with the do, okay? And the conclude. So hopefully that will break it up for you a little bit so it won't be too bad. Okay, so here's the problem. We have clothing for runners. Give me a second here. Let me adjust this here. Okay, so your company sells exercise clothing and equipment on the internet to design clothing. You collect data on the physical characteristics of your different types of customers. Here are the weights in kilograms for a sample of 24 male runners. So they give it to us below. Find a 95% confidence interval for the true mean weight of the male runners. So for the state, before it was, your state was talking about the parameter P. Now our parameter is called mu, and that's actually a Greek letter, and I'll draw that for you. Whoops, I don't want to be on highlighter, forgive me. Mu looks like this, okay? Mu is a parameter that's describing the average about an entire population. So we're wondering about the true mean or average weight of all male runners, okay? And so since I'm typing everything, the way you spell mu is MU. And just like before when we said it's always the true, it's still the true. But this time it's always going to be the true mean of something, whatever that story is. So you guys are always going to say the true mean. And then what you're going to do is you're going to fill in the blank right here. What's the story about? And in this case, the story is about the true mean weight of male runners. So on all of your problems, you're going to start off with mu is equal to the true mean, and then fill in the blank that I have right here. In this case, it's the weight of male runners. So that's the state. We're done with that. Now we're going to move on to the plan. This is still our conditions. Our conditions are so we can use our measurement tool. And that measurement tool is that confidence interval, okay? And the plan are those conditions there. So let's get going on the plan. The first condition is R. That's our random sample. This is just like we did before. So we have to show that we have a random sample, and it does not state that it's a random sample. So what you can do is you put in here, assume, okay? And that's okay. Statisticians do base things off of assumptions, and then people have to understand that it's based off of an assumption. Okay, so we're assuming that it's a random sample of 24 runners. The next one is I. So we're still using that acronym of RIN for the conditions. I we take, and this is just like we had before. For the I, arrow over here, we take 10. It's not a very good 10, I'm sorry. Times the sample size. Has to be less than the population size. And often we don't know the population size, and we don't know the population of all runners in this case. Okay, so I'm going to take 10 times 24 because that's our sample size. Has to be less than all runners, and that's very plausible. I think there's many more than 240 runners. And to be honest, I should have put male runners, but it's okay. The next thing is our N condition. And before we did this, NP has to be greater than or equal to 10, and an N times 1 minus P has to be greater than or equal to 10. This time, we don't care about this. This time, there's this magic number 30, and that comes from something called the central limit theorem. We talk about that in AP statistics, why it's 30. We do not talk about that in intro to statistics or regular statistics. You just need to know for the N, we always want to make sure that our sample size is greater than or equal to 30. That's the condition. Now, it is not in this case. And one thing you need to know, and this is when you go to college and you explore this more, you'll get into this, but the T distribution is very what we call robust. Okay, so it can work if our sample size is not greater than or equal to 30, okay? But what has to happen is you have to graph this data, okay? And you have to make sure that it can have a slight skew, or we would like it to be symmetric, but there can't be any outliers. Since we're not in AP stats and we're not in college stats yet, we're gonna go ahead and say you can assume this so you don't have to graph it. Make your life a little bit easier, especially the year 2020 with all this COVID stuff. We want to make it as easy as we can. At the same time, we're learning about this confidence interval. Okay, so we would just go on to state, well, 24 is not greater than or equal to 30. So we assume the graph of the data is slightly skewed, which would be okay, or symmetric, and it has to have no outliers. If N is greater than or equal to 30, you would just state it. So if, let's say it was 32, you would say 32 is greater than or equal to 30. We're good to go. We don't need to state anything about the graph then. And then finally, with the plan is our method. We're doing a one sample T interval for mu. So that's what you need to know today. Let's quick recap the 3 things you need to know. How to find a T star using those degrees of freedom. What does the state mean? It's always the true mean. Fill in the blank. Our conditions, our plan, the R for random, the I for independence, the N has to be greater than or equal to 30. If it's not, that's okay. Let's go ahead and make an assumption that the graph of the data is not too skewed or it is symmetric with no outliers. If you have any questions, make sure you reach out, you guys, and have a great day.